Hello, today I have make a video on Fanuc custom macro B, and today we will use a custom macro to cutting some helical groove on a cylinder. So what I got here, as you can see, this is the cylinder, and we have some groove, helical groove. You can see here. I will create a custom macro program to cutting the groove, and the cutting is done on a 4-axis machine. And for example, I have a horizontal 4-axis machine here with the B rotator axis. This is the B axis, okay. And this is how the cut is performed. I will reset the simulation, and so you can see this the cutting. Yeah, this is the cutting. Okay, and I will show you the macro here and do some explanation. Yes, you can see here this is the macro I created before. Like normally macro program, we have some variable to define some some value. Okay, you can see this area is for a user to define the variable value, and this area for calculation. For this program, for this macro, we need some parameter. So you can see here we need some parameter for the groove. Is first is the number of grooves. So you can see here I have 1, 2, 3, 4, 5, 6. I have 6 grooves on this cylinder. So the first variable is the number of grooves. You can see here. In this case, I can input 4. And the next variable, the next is the variable with the 1.2 is the helix angle. So you can see this the helix angle of the groove. Yeah, and the next the next variable is the tool diameter. That's mean the cutting tool diameter. For example, 10, 11, 12, 16, or 20, 25 millimeter. The next parameter is the cutting diameter. What's this mean? The cutting diameter is the diameter on the cylinder the tool make the cut. For example, here I have a cylinder with the diameter of 200 millimeter, and the groove is 1 millimeter depth. So the cutting diameter is 198. Yeah, so you can see here I have the cutting diameter is 198. That means the depth of the groove is 1 millimeter, because the stock is 200 millimeter. And the next parameter is the tool travel distance. Because this machine is horizontal, so this axis is the y-axis. So I make a note here. You can change the variable to fit your machine. Change some variable. So we have the tool travel distance. That means that's the distance from the beginning of the tool to the end of the roof. Calculate under axial direction. That means from here to here. Oh, sorry. And the next parameter is the start point clearance. That means how far the cutting tool needs to stay away from the stock to avoid collision. In this case, I input the 2 millimeter for clearance. And the next variable is a counting variable, just for for do calculation is a looping variable. We use this on the loop circle. Okay, so the first error is the error for the user to input the parameter of the groove and the stock, the tool. And the next error is for calculation. I make some calculation here. First, I make a calculation for the indexing angle. That's index angle is the angle between from one groove to another groove. For example, we have 4 grooves, so the index angle is 90 degree. The variable number 108 is the index angle, and the 109 variable is the start point coordinate. That means the coordinates of the tool before it do the cutting. It's calculated by we use the tool radius plus with the clearance here, start point clearance. So we got the start coordination, and this variable is it will calculate the circumference at cutting diameter. So you can see here with this cutting diameter 198, we can calculate the we can calculate the circumference of the cutting of the cut. So in this case, I got the circumference is calculated by 104. So you can see 104 is the cutting diameter. Multiply with the P, and the P here is 3.14159. Yes, that's enough for the P. We can calculate the circumference at the cutting diameter. The next step, we calculate the arc length. The arc length is calculated by we use the travel in the y direction multiply with the tan of the helix angle. So we got the arc length here for the travel. After calculate the arc length, we calculate the rotary angle for the b axis by at first we make a division with the calculate arc length and the circumference, and then we multiply with 360 degree, so we can calculate the total value for the b axis rotary angle. After we calculate all the variable, we move to the main program. So you can see here is normal program. I can see here the start point for z direction. Yes, we have the cutting diameter divided by 2 to provide the cutting point z coordinates. And you can see we with this macro we have a loop here. At first I use time inverse feed rate Z93, and we have some two motion here, a combination motion between the y-axis and the b with the inverse time feed rate here. When it's moved to the end of the stroke, it will reverse here with this line, with this block. And there's thing to note that I use the incremental mode. After is the make the cutting, the b-axis will do the indexing with the 1.108 index angle. After indexing angle, I use the variable 107 to do the loop. Yeah, you can see here the new value of this variable is equal to the old value at 1. So the loop continue until this condition. The loop will sorry for my English. This loop keep happen until this condition is fail, and when the condition is fail, it stop the loop and is move to this line. If this condition is true, the loop is continue, is go to the end true and do the same thing here. Is the cutting indexing. After all, it will finish here. Yeah, after the loop it will finish. So I will show you how it's work here. This macro is simulate by varicut. Okay, I have the program here. I will so you can see here I have the macro had already import here. I will open it. Oh, sorry. It's my macro. I will check it, and I will make some modification for you to see the difference. Here you can see our helix angle is 45 degree. Now I will change it to 10 degree to let you know what happened here. I will delete this and edit this. Okay, I will change it to 10 degree and save it. Alright, now I import it again. Select our program here. Okay, and now we check the new value of the helix angle. Oh, sorry. Here, this is the very first time I use varicut, so I'm not familiar with it. So you can see here's the helix angle. New helix angle is 10 degree instead of 45. Now we run the program again. So you can see here the helix angle had changed, and we have 4 groove here. So now I want to make a deeper groove, a longer groove with the same helix angle but longer. Okay, again I will change the program. First I need to close this first. This will let me change the program. If I don't delete it, I can save the new one. So we keep the helix angle is the same. Now we change the number of groove to 9. Okay, or even 10 groove, and the tool diameter is as 15 or 20, 16. Okay, let me check the tool diameter. Okay, the tool diameter is okay, we got the number 1 tool is the 30 millimeter. Okay, it's 30 millimeter. Alright, and the cutting diameter, now the groove we want make it deeper, so the cutting diameter is reduced to, now I want to get a 4 millimeter cut, so the cutting diameter is 192, and the travel distance I want to make the groove longer. I will go about 5 200. Okay, and okay, we save it. Oh, sorry, I need to close this first. I need to select another file in order to save it. Okay, okay, now we can save it. Right, and now we selected it again. We select the DSR program and check it. So you can see here the new macro with the helix angle is the same, the 10 degree, the tool diameter is 30, and the cut diameter now reduced to 198. Tool travel distance is 200 longer than the previous one. Okay, and we need to reduce the feed rate if you want. Reduce the feed rate here. Okay, now we run it. I will run it for you to see. We can reset the simulation, reduce the speed a little bit, and oh, there's some problem here. Oh, there's some problem here. Let me check. Oh, I lost the program. Now to input it again. Okay, now I will run it again for you to see. A new program, a new parameter. Okay, zoom it a little bit closer. Yeah, you can see we have the deeper groove with the deeper and the longer, and yeah, you can see here this is our park. Okay, thank you for watching. I hope that can help you to make a good macro program. This is the sample program with just one depth cut. If you want to make multiple depth cut, you can do the same way, but we need to do some modification here in the loop for multi depth cut. Thank you. Bye bye.